Hello, welcome back to the channel. So let's do one more question on definite integrals using substitution. So in this question, we'll also discover a new property of solving definite integrals using substitution and identifying a common pattern based on these type of questions. So again, the same thing about substitution that we also covered in the last videos. If you have not watched the previous videos, I would highly suggest you to first watch those videos in order to get the full explanation of these videos. And a quick recap of what substitution is. So whenever we have to use substitution in our evaluation of definite integrals, we usually identify our function for which the derivative of that function is also given in our integral expression. So if we have to solve this question, if I identify a function for which the derivative of my function is also given, I can use substitution in order to solve this question. And I can clearly see in this question that, so for example, in this case, if I assume the function to be x, let's suppose, so I know that the derivative of x is 1. There is 1 present over there, but I can't do much with it, right? Because there is a log x expression as well, and if I change my function from x to something else, it won't help me a lot. So now let's move on to the next function we have in this expression. So we also have log of x, and I know that the differentiation or the derivative of log of x is 1 by x, and I also have 1 by x in the expression. So this gives me a confirmation that I can definitely assume log x to be my function, and I also have the derivative of log x in this expression, in this integral expression, that would help me to use substitution in order to evaluate this definite integral. So let's start with writing that function. Let's suppose that function is denoted by u, which is log x. If I take the derivative of u with respect to x, it would be 1 by x. So du, if I shift the dx to the other side, it would be 1 by x dx. And now I can clearly use substitution, right? I can just change my log x to u, and I can change my 1 by x dx, which is over there, to du. But before we do that, we also have to take one thing into consideration, one important thing into consideration, that since we have used substitution in this case, we are changing our dx to du. So that is why we have to adjust our endpoints based on u function, based on the u values instead of the x values in this case. So if we have to convert our endpoints, since our endpoints in this case in terms of x is x equals 0 to x equals e to the power 4, but now in this case, in order to use substitution, I want my endpoints to be based in terms of u. So I know that when my x is equal to e, my u is log of e, right? And log of e, which is natural log of e, is 1, right? Remember, this log is the natural log to the base e. Whenever we consider this log expression, it's always the natural log. So we have, when x is equal to e, our u is equal to 1, which would be our lower endpoint, and when our x is equal to e to the power 4, our u would be log of e to the power 4, and because of the property of log, the power can come in front, right? So it would become 4 log e, and this log is also in terms of base e. So our upper endpoint in this case would become u equals 4. I hope it's understandable at this point of time. Feel free to comment down if you still didn't get this part. I'll explain you in the comment section as well. So now we have changed our endpoints in terms of u. So the lower endpoint has now become u equals 1. The upper endpoint is u equals 4 in this case. So now let's do all those substitutions. But before doing all those substitutions, let's write the original expression, which was 1 by x times 1 by log x dx. I've just simplified this expression. This is again the same as dx upon x log x, right? And the endpoints were starting from e to the power 4. And now let's further simplify this down so that we can easily visualize our substitution. So I can write this as 1 by log x and combined with 1 by x dx. Now, in order to use substitution, we'll change 1 by x dx to du, and we'll change 1 by log x to 1 by u because our log x is substituted to u. And when we'll change everything to u, to du expression, we will change our endpoints as well. So this would become 1 by u, 1 by x dx would become du, and the endpoints will be changed to u equals 1 to u equals 4. And we clearly know the answer, the integral of 1 by u, which is log of mod u. So it would be log of mod 4 minus log of mod 1. Mod is the absolute value. Since 4 is positive, so it would be log 4, 1 is positive as well, minus log 1. So this is the final answer. And that is done by only using substitution in order to evaluate our definite integral. But based on this, you'll also note one more important observation in this case, that whenever you have to calculate an integral, we will take an indefinite integral because it's easier, we'll not have to deal with endpoints. But whenever you have this type of expression, when you have the derivative of that function in the numerator and you have your function in the denominator and you're calculating the integral of that expression, the answer to this integral would always be the natural log of f of x, and the natural log, which we also denote as log to the base e. So you can always write the answer of this integral to this one. So that is a pattern. Whenever you have to calculate an integral for which you have the derivative in the numerator and you have the function in the denominator, the answer would always be log of f of x. And it would be indeed log of mod of x, because log is always positive, right? So that is why whenever you have to calculate, and remember that log would be in terms of base e, so whenever you have this expression, you can always simplify this integral to that expression. And you can also clearly see in this case as well, you had the derivative of, for example, in this case our function was log of x, so our log x was in the denominator, and the derivative of that function, the derivative of log x, is 1 by x. So if we compare 1 by x, our 1 by x is actually in the numerator, right? So we have 1 by x in the numerator and we have log x in the denominator. So that is why our answer to this question was log of u. The integral of this was log of u, and u was our original function. So that is an important point that you can also take from this video, that whenever you have these type of integrals, you can always use substitution, or you can always use the answer to these integrals as just this one. And if you're calculating the indefinite integral, of course you'll have a constant of integration in each of these cases. So that's it for this video. I definitely hope you found this observation useful. Feel free to comment down on this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.